we are looking at function machine. Now, before we move forward, we need to remind ourselves about an equation. We know that we have basic linear equation whereby it has y is equal to x has basically no power because normally it has power 1 and we don't keep power 1 since it means the same power. So we have a linear equation. At the same time, we also have a quadratic equation whereby the biggest power is power 2. Also, we have a cubic equation, and in this case, in the cubic equation, the biggest power is power 3. Now, if you remember about equations, we say normally that equations always have equal sign, right? And we have our x and y. X is equal to something. Now, when we are bringing in functions, we use letters. Example, fx, gx, hx, so on. These always represent the y. Any function is always equal to y. So as you can see here, the previous function fx is equal to x minus 4 is the same as the equation y is equal to x minus 4 because any function is always equal to y. So when we have a function, if we look at any function, for example, fx is equal to x minus 4, right? The value which is inside the bracket, that's always the x value. That's always the x value. And the whole of this side expression is always the y value. Now let's see what is an input and what is an output. The x value always represents the input. And the input is what you keep. The input is what you keep into a function. Y always represents output. And the output is what comes out of the function. So this means in a function, we have what we put in, and that is the x, and then we have what comes out, and that's the y, right? So the x is known as input, and the y is known as output. Sometimes also the x is known as the domain, and y is known as the range. These are different names given to x and y when we are dealing with the function. What do we mean with the input? Take an example. we have our function above, which is x minus 4. And we say this is exactly the same as y is equal to x minus 4. And when you take this function and give any values of input, for example, 1, 2, and negative 3, give any values of input. These values of input will generate for you the values of output. And we say output, we use y. Now, when you look at these inputs, right? If I put 1 to my function x minus 1, then it will be 1 minus 4, and my output will be minus 3. If I keep 2, it will be 2 minus 4, and my output will be minus 2. If I keep negative 3, my output will be negative 7. That is if I follow the rule of integer. So this is what it means by input to get output. So whenever we use the arrows, this is representing mapping. This is representing mapping diagram. So mapping diagrams can be written in different ways. And for example, I can put them in a straight line, and I say my input can be, and I put different values on a line. Let's say negative 4. This is the input, and then I can have my output line where I also keep other values. Normally, we have to have equal number of values, but since I have a negative 7, it means that's from negative 7. So when I keep my number line, then I use an arrow to direct the input so that I show my output. So if you look properly, in our previous question here, when we kept the input as 1, we got the output as minus 3. When the input was 2, we got the output as minus 2. And when the input was minus 3, we got output as minus 7. So this is what we call mapping diagram. Now, when we are dealing with a function, we must always know an input and an output. Today, we want to focus on a function machine. But before we go to function machine, let's see how a function can look like and how we deal with it when we want to find, you are given an input, that you find output, and when you are given output, that you find input. So here is our example. We are given our function, which is fx is equal to 3x minus 5. As we said before, the value inside the bracket is our input. The value inside the bracket is our input, and we know input is x. Now from this function here, which is 3x minus 5, what we do is we get our input 3, and we multiply to 3, we get 9. Then after getting 9, take the 9 and we minus 5. And we get 4. And 4 is our output, given 3 as input. So this 4 is basically our output. But here we have our input as negative 2. So we shall take this negative 2. Shall take the negative 2. We shall multiply it to 3 because on our function we have to start with multiplying 6. And we shall get minus 6. So we shall get this negative 6. And then we subtract 5. It gives us negative 11. And therefore, negative 11 will be our output. Let's look at this last part here. If you look properly at this part, you will realize that now we are not given input. We are given output. Whenever we are given output, we have to work out the reverse of the given function. What is the last? We do first, and we do its opposite. So we shall take our output is 1. Okay? Now, before we had 3 and minus 5. So first now we have to do the opposite of the last act, minus 5. So we shall plus 5 and we get 6. Then after getting 6, then we have to do now the opposite of times 3, and that is divided 3, and we get 2. So now we get our input as 2. Remember, when we are given the input and we are when you are given output and we need to find the input, we will do the reverse or the opposite of the original function. And what is that opposite? If we have more than one function, the function part done last, we will do it first in its opposite. And the act done first, we will do it last on its opposite. Remember, the opposite of plus is minus. And the vice versa, the opposite of minus, the opposite of times is divide. And vice versa, the opposite of divide is times. But don't forget, the opposite of square is square root. And the vice versa is the opposite of square root is square. Now let's look at function machine. So first of all, when I have my function, right? Because we say a function has a length. First, change the function to become equation. Change the function to become equation. Now, the machine is given as follows. First, indicate input. After indicating input, draw an arrow. Then look at your function. What act do you do? The act we do is subtract 4. Then after subtracting 4, we shall get our output. So this is what we call a function machine. Let's look at another example of function machine. Here, number 2. When we have that function, basically, change the function to equation. Change the function to equation. Now take this equation and draw a machine. We shall have our input. Then the first act will be multiply 3 because that is the nearest to x. And remember, our x is our input. Then after multiplying 3, we will subtract 5. Right? Because here we multiply 3, then after we subtract 5. By doing that, then automatically we will get our output. Right? So basically, change the function to equation. Then after, draw the machine. So in order to draw the machine, we need to know what is the first act. And the first act here is to square our input. Our first act is to square our input. Then after squaring our input, we will subtract 3. Then after subtracting 3, then we are going to obtain our output. So in a machine, it's very, very, very basic. Just need to always remember what is our first act and then what is our second act. After remembering that, then we will obtain our machine. So let's see our last example here. Change the function to equation. Then after changing to equation, then draw the machine. Get the input. Now, if you look properly here, the first act to our input is to square. Right? Then after squaring, the next part here is to multiply by 2. Then after multiplying by 2, the last act is to subtract 10. And after doing that, we will get our output. Right? So this is what we call a function machine. Remember, if I want the reverse of a function machine, then I have to start from the back. What is the last? I call it the input. Then I go backward. What was done last, I do the opposite. And since it was subtract 10, then I will plus 10. Right? Then, after subtracting 10, we had to multiply by 2. Now, when I do reverse, I will divide by 2. Then, the first act was square. But because I'm doing reverse, I will do the square root. Because the reverse of a square is a square root. So this is how I can do the reverse. So normally, when I am starting from the input, I follow exactly what the function says. But when I'm given the output, I will use that output as my beginning input, and then I do the reverse. So this is what we call a function machine. So now we are going to do practice. When you're going to do practice of questions, when you are given the function. So here we have our question. We have got the function machine and we are told, what is the output when the input is 7? All right, if the input is 7, then what is the first act on the machine? Is multiply by 5. And when you multiply by 5, you get 35. After getting 35, what is the next act? Subtract 3. And when you subtract 3, you get 32. And therefore, our output will be 32. Right. B. Here is a different machine. Look at it. The machine says add 11, then do another act in order to get the output. So we are given when the input is 9, okay? When the input is 9, the first act is saying add 11. And when I add 11, I get 20, right? Then when I have 20, what do I do to 20 so that I get 2? Right, I have to ask myself, what do I add or do I subtract? I divide. So basically here, I have to divide. If I divide this by 10, then I will easily get 2. So I will put my input, I'll fill my machine with divide by 10. All right, let's go to another example. There. So in this question, we are told, first multiply by, then so here A says, find the output when the input is 6. So if my input is 6, I will multiply by 4. And then after multiplying by 4, I'll get 24. Then after getting 24, the next subtract 7. Then I get 17. So therefore, my output will be 17. B, find the input given the output. Now, because I'm given the output, I have to do the opposite, right? So since my output is 25, go back to your machine. Instead of -7, you will do +7. So I'll come here and I +7, get 32. Then this 32, go back to your machine. Instead of multiply by 4, then do the opposite, divide by 4. So I'll divide by 4 and I'll get 8. So here I have obtained my input for B, and my input will be 8. So let's go to example 3. Find the output given input 12. So when you're given input 12, the first act on the machine is divide 4. When you divide by 4, you get 3. Then after getting 3, the next act on the machine says 5. And we get 8. So automatically our output. Let's go to B. Find input when the output is 13. Right? When you're given 13 as the output, meaning the last act is +5, we do the opposite, which is -5. Right? So it's like we are going back. So I will -5. And when I -5, I get 8. Then after getting 8, I continue backwards. Instead of dividing 4, I will multiply by 4. So 8 times 4, I'll get 32. So my input now backward will be 32. Right. This is how we do, how we solve questions using the machine. Let's proceed for more examples and practice. Find output when the input is 3. The first act is times 6. Then I will get 18. After getting 18, I go to my next act. And my next act is +2, which gives me 20. So therefore, my output will be 20. B says, find input when the output is 44. Find input when the output is 44. So if I have my output, remember, I have to do the opposite. And the opposite of the last act is -2. That gives me 42. Then after getting 42, I go back to the machine and I have to do the opposite of the first act, which was times 6. So now I will divide. So when I divide by 6, I get 7. So therefore, it means my 7 will be my official input because I was given output as 44. So let's go to another example. This is all practice of using input on a machine or output on a machine. A, find output when given input as 81. So if my input is 81, first article divide 9, my first article gives me 9. Then after getting 9, I go to the next act, which is minus 5, and I get 4. Hence, my output will be 4. B, you are given output as 0. Do the opposite act, which is plus 5. I get 5. After getting 5, then you have to do another opposite of divide 9, which is multiply 9. I'll get 45. Hence, my input will be 45. Next example here, again, we are given here. Input is 5. Multiply by 4, we will get 20. After getting 20, the next item plus 7 is 27. Hence, our output is 27. B, we are given output as so if our output is minus 3, do the opposite act of plus 7, so do minus 7, and you get minus 10. Then after getting minus 10, do opposite of times 4, which is divided by 4. Right? Are we together? After dividing by 4, because we're doing the right? Oh, in B, let's get clear. In B, we are still given the input. Yeah, look, this is still input. It's not out. So because it's still input, I will follow the same machine. Right. Thank you. So I will multiply by 4 and I get minus 12. Then after getting minus 12, I will get plus 7 and I get minus 5. Then after getting minus 5, and that will be my output. So from the output, I will follow the next step. From the output, I will find the next part. Now here I am given the output. My output is 71, right? So I have to do the opposite of the function. Now, the output will be I will do the opposite of the function. I'll do the opposite of the function. Remember, on my function, I had plus 7 left. So this time, I do the opposite, which is minus 7. And after minus 7, I have to divide by 4. So let's do that. So if my output is 71, I will do the opposite by minus 7. And I will get after getting 64. Now it was times 4, I will do divide by 4, and I get 16. Right. Let's go to example 7. We have 3 questions. First question, input given. Second question, input given. And the third question, output given. Right. So when I'm given input 5, I multiply by 5, I get 25. Then the 25, I will plus 9, and I'll get 30. So my output will be that. Next one, I'm given input as negative. So I multiply by 5, I get negative. Then this negative 10, I plus 9, I get negative 1. So my output will be negative 1. But for this last part, I'm not given input, I'm given output, which is equal. So because I'm given output, I have to do the opposite of plus 9, which is minus 9, and I get 55. Then after getting 55, I have to do the opposite of times, which is divide by 5, and I get 11. And I obtain my input as 11. All right, let's do our last example for the class. Let's do our last example, number 8. So in this question 8, we are still given a machine which says multiply by 3 and then subtract 6. All right. So first we are given the input 4. So I will multiply by 3, I get 12. So this 12, I will subtract 6 and I'll get 6. So hence my output will be 6. B, I'm given output, which is 15. I have to do the opposite. Instead of minus 6, I have to do plus 6. And I get 21. Then this 21, I have to divide by 3. That is the opposite of times 3. I get 7. Hence, my input will be 7. Right. We are concluding with one of the most important basic tricky questions. Show that there is a value of the input for which the input and the output will have the same value. Now, this question, we can do it in 2 different ways. Number 1, we can use what we call try and improvement. Try and improvement means try out any input value until you get the value which gives you an answer. E.g., you can say, let our input be 0, right? Then you multiply 0 by 3, you get 0. Then you subtract 6, you get minus. Right. Then you can say, let's try 1. You multiply by 3, you get 3. You minus 6, you get minus 3. Still, the input and the output are not the same. You have to continue until you get the value which is the same, right? If I put 2, for example, as input, and I multiply by 3, right? And I'll get 6. 6 minus 6 will give me 0. So still, my input was 2, my output is 0, right? I continue. If I put input 3, I multiply by 3, I'll get 9. Then 9, I subtract 6, I get 3. Okay, now I kept input 3, and my answer, I've got 3. That means the value is a 3 that will be working. This is using what we call a try and improvement. However, we can use equation. Remember, we say input is x. So if my input is x, using equation. If my input is x, so first axis times 3. So my equation will be x multiplied by 3, and then minus, okay, then I should get my output. So if my output is the same, so I can say, for example, let both be A. So it will, the question now will be, since they're the same, it will be 3A minus 6 is equal to A. Since the output and input should be the same. So to find now the value here, I have to collect like terms, right? So since I have 3A this side, I have to bring the other A this side. So since it was a positive A, it will be minus A when it comes this side. And minus 6, I have to take it to the other side. Since it was minus 6, when I take it over the equal sign, it will become plus 6. But remember, 3A minus A, I will get 2A is equal to 6. I divide by 2, hence I get 3. Hence now, I know using equation, I got 3, and using find improvement, I get 3. So here, my input was 3, and I got output as 3. Thank you so much.